In this lesson, you will learn how to match graphs to their stories. It is very important that you pay attention to the details. When reading word problems, I always encourage you to read them 3 times. The first, you'll read and just get familiar with the problem. The second, you reread and pick out the important information. And then the third is actually after you've worked the problem, you read it the third time to make sure you've answered the question that it's asking. Let's look at our examples. Lillian left her house and drove to the store. She stopped and went inside. From there, she drove in the same direction until she got to the bank. She stopped and went inside the bank. Then she drove home. The graph below shows the number of blocks away from home Lillian is X minutes after she left her house until she got back home. We want to find the rate Lillian is driving away from her house at time X equals 1. So that's our first read of the problem. We would reread the problem to pick out the important information. So when you do that, you identify on the graph where her home is, where the store is, where the bank is, and get yourself familiar with the graph. Now let's answer the question. We want to find the rate. So a rate is going to be our slope. The rate that she is driving, we can count, rise, and run. So actually, let's zoom in on that portion of the graph. So this portion of the graph will tell us the rate Lily's driving. At time equals 1, so looking at 1 here, if we count rise and count run, it is a constant rate of change during that section. So you can count from any 2 points. Because it's wanting at time 1, I do encourage you to start there, but you could rise 4 and run 2, which also reduces to the same slope. So at time equals 1, Lillian is driving away from her house at a rate of 2 blocks every 1 minute. So now would be a good time to go back and reread the problem for the third time, making sure that you didn't misunderstand anything and that you actually answer the question being asked. Let's look at the next example. Caleb left his house and drove to the store. He stopped and went inside. From there, he drove in the same direction until he got to the bank. He stopped and went inside the bank. Then he drove home. The graph below shows the number of blocks away from home Caleb is X minutes after he left his house until he got back home. At what rate did Caleb travel from the store to the bank? So we read the problem the first time. We could reread the problem the second time to identify each parts of the graph. We have our home when he stopped at the store and bank. We're reading the second time to identify those. And now we answer the question. At what rate did Caleb travel from the store to the bank? Let's zoom in on that portion of the graph. So during that section, count, rise, and run again from any 2 points. So there's a point here, we can rise and run, or you can even start here. So counting rise and counting run will give us that rate of change or slope of the line. So rising 3 and running 1, Caleb traveled 3 blocks every 1 minute. Now would be a good time to reread the problem a third time to make sure, again, that you didn't misunderstand or that you've actually answered what it's asking of you. Let's look now at the next example. Enola left a house, drove to the store. She stopped and went inside. From there, she drove in the same direction until she got to the bank. She stopped and went inside the bank. Then she drove home. The graph below shows the number of blocks away from home Enola is X minutes after she left her house until she got back home. How many blocks is it from Enola's house to the store? So if we look, she would start at home, left and got to the store. This is what we're labeling during the second reading of our problem. And then we have the bank. Our question asks how many blocks is it from her house to the store. So we're not needing the rate of change here like the two previous problems. We want to know how many blocks. So we travel to the store. Here's when we're at the store. So when we arrive, that tells us 3 minutes passed and she's at 12 blocks. Paying attention to the X and Y axes because it asks how many blocks. We want to use the Y axis. So the store is 12 blocks from the house. Let's look at the next example. During a snowstorm, snow fell at a constant rate for a number of hours. Then it stopped snowing for a number of hours. Then it started up again at a different constant rate. Lily made a graph showing the inches of snow on the ground over time using the data she collected. So we want to know how much snow was on the ground when the storm started. So we could reread the problem to help identify. Here's the part where it's snowing. Snow stopped, and then it went again. But we know that this is a different rate or slope because it has this, it started up again at a different constant rate. That's why our slopes of those portions of the graphs are different. But our question is actually wanting to know about the snow that was on the ground when the storm started. So if it's wanting the part where it starts, we're going to look here at the y-intercept. So here the y-intercept, time is 0, so that's before it ever begins. How much snow was on the ground, that's going to tell us our starting amount. And the snow on the ground, our y-axis, tells us that it is 4 inches. So there are 4 inches of snow on the ground. Let's look at our next example. Xavier left his house and drove to the store. He stopped and went inside. From there, he drove in the same direction until he got to the bank. He stopped and went inside the bank. Then he drove home. The graph below shows the number of blocks away from home Xavier is at X minutes after he left his house until he got back home. So here we are at home, driving to the store. He was in the store for a quick shopping trip, just 4 minutes, and then he left and went to the bank. There again, he was in the bank just for a couple of minutes, and then he drove back home. Because home, looking at our y-axis, is the distance from home, that's why we're back here at 0. So we drove to the store, kept driving, and got to the bank, but then we returned back home. So how long was Xavier in the store? That is this section of the graph of 4 minutes. Let's look at our next example. Here we're going to choose the graph that best represents the situation. So we have each day several leaves fall from a tree. One day a gust of wind blows off many leaves. Then the leaves continue to fall from the tree. Eventually there are no more leaves on the tree. So that's our first read of the problem. We read it a second time now, identifying the important information. So each day several leaves fall off of the tree. Well, we see the first graph shows an increase of leaves. As time was passing, that rate of change is increasing. So that would be leaves growing on a tree. The next graph does show a decrease. If we're having leaves fall from a tree, this does show that happening, as well as graph C. Our next part says the gust of wind blows off many trees. So if we're going to have a wind blowing off, that means more are going to fall. The amount of leaves is going to decrease. And notice that rate of the graph, it changed because the gust of wind is going to make more leaves fall off quickly versus just the beginning of the story where just some of the leaves were falling off. That gust of wind is going to blow off more leaves at a time. This graph for graph C shows no changes in the amount of leaves. So yes, they fell off to begin with, but then there was a period of time where the leaves stayed the same number on the tree. So really at this point, we could pick graph B, but let's finish off the rest of the story. The leaves continue to fall from the tree. So we see that in this graph. Eventually, there are no more leaves on the tree. So we definitely would see that in this graph because at this point where the leaves are falling off, and over time they get down to 0. This means there are no more leaves. When it gets whatever time passed by, the leaves are at 0. We can now read the question a third time to make sure we have actually answered the question, which is, going back to our directions, choose the best graph, which is graph B. Let's look at our next example. We want to choose the graph that best represents the situation. The air temperature increased steadily for several hours and then remained constant. At the end of the day, the temperature increased slightly before dropping sharply. So let's reread this to get that important information. We see an increase steadily. So graph A actually starts off with a constant, where the temperature is not changing. So a constant temperature here. Also, graph B shows no change in that temperature. So whatever temperature it is not changing when it is that horizontal line. No rate of change there. After that, it remained constant. So there on graph C, let's look at graph C. There's our increase and then the remain constant. At the end of the day, the temperature increased slightly. So we see that here in graph C before dropping sharply. Because it's dropping sharply, that's why that slope or that rate of change is so steeply decreasing, because it's dropping very, very quickly. So that's to make that slope or that rate of change be very steep. So it would be graph C. Now we're going to match each situation to the graph that best represents it. So our first one, I left home and before going to school, I stopped to eat breakfast at a restaurant. The second one says, I left home thinking I had plenty of time, but sped up when I realized I was going to be late. And then the third one, on my way to school, I realized I had forgotten my backpack. I went back home to get it and then quickly hurried to school. So once I read through and know kind of the options, let's go back and reread. The first one does match to graph B. I left home. So let's look at graph B. Our distance from home, being very careful to notice the y-axis. Distance from home is going to increase. This period of time is when they're at the restaurant. So leaving home, I stopped to eat breakfast at a restaurant. I left home and before I go to school. So yes, it did continue off to school. The next one would match with C. I left home thinking I had plenty of time. So we're traveling down, doing just fine as time's passing by. We're just getting a little bit away from home as we go. But then we speed up when we realize we're going to be late. So time is still passing by, but look how our distance from home starts getting faster and faster, or getting further and further away because we're driving faster and faster. Okay, so the y-axis is the distance from home, but it is also showing us how we drive faster, about our speed. The time's passing by. We didn't get very far from home at the beginning because we were just kind of slowly going. But as time passed by, we drove faster and our distance would continue to increase more and more. The next one, on my way to school, I realized I'd forgot my backpack. So we left here, headed off to school. So we left home. This is the point that we turn around. So time's passing by. We had to turn around and head back to the house. So notice distance from home, we're going to start getting closer and closer to home. This here, when distance of home is at 0, if our distance from home is at 0, that means we're in the house. We're looking for that backpack. So on my way to school, I realized I had forgotten my backpack. I went back home to get it and then quickly hurried to school. So we were leaving, getting back to the house. Here's the section we're looking for our backpack, but then we have to quickly. So notice also how that rate of change is slightly different than when we first maybe left the house, because we have to hurry now since we had to turn back around to the house. So here our slope or our rate of change is also different. So when matching graphs with stories, always be careful with the details. Read the problem multiple times. There may be something you overlooked the first time, and then just to be able to point out that important information, rereading it will help you identify that.